All right, everyone, how you doing? This is the Bridge for Math Dr. B coming at you. Doing something a little bit different in this video. I'm going to start with the answer first, kind of like the Jeopardy game. Here's the answer, and then we'll figure out the question. So I want you to look at this complicated looking graph. In money green is the actual solution to a particular function or an equation. So a graph represents the solution to an equation in green. Notice it's got three different pieces. Very complicated. It's not your typical linear graph. This is curves, exponential looks. Kind of frightening, to be honest. But I want to point to some things that appear to be in different colors and maybe not even part of the graph. So let's look at these vertical, sexy red dashed lines. X equals 5, x equals negative 5. You're going to learn in this video that they represent something very important to help you graph. They're called vertical asymptotes. Crazy word, asymptote, but they're vertical asymptotes. This blue line that's dashed is a horizontal asymptote. And I want you to look at the graph of this function and see, do these asymptotes almost behave as fences that guide the graph? So, given that I'm at Feather River College right now, we have equine studies, big time program with horses. I joke around with my students. Imagine you have a horse over here, it's running free, but these asymptotes kind of control where the horse can go. So when it comes to math, the asymptotes guide how the function behaves. They help you understand how the function will behave. For instance, what would happen as x becomes big and negative if you put it into the function? It looks like it starts to flatten to be a certain value. And it turns out that output value is y equals 2/5. So right now you might be feeling overwhelmed. It's kind of like drinking from a fire hose, so I apologize. But this is going to make sense, just bear with me. Starting with the solution of what the graph would look like, trying to show you what asymptotes actually are, what visually they are. Vertical, horizontal. They kind of help you graph. So now you've seen the answer, let's kind of go back to the question. What is the question? Question, basically, let's look at this function, a function f of input x. Yes, it's a fraction. They call it a rational function. Quit laughing. There's nothing rational about fractions. I know what you're talking about. But you have 2x squared on top divided by 5x squared minus 125. So you have this really interesting function, and they want you to find the asymptotes. So like I told you, I started off with the answer. The asymptotes are x equals 5, negative 5, x equals positive 5, y equals 2/5. Well, how did we get there? Well, you could be diabolical and sneaky, which I encourage my students to try. You could go to a website called wolframalpha.com, and I'm not getting any money to promote this, but I actually go to this website to graph things on the internet. So you can go to a website, tell it to plot or graph the function. I actually gave you the code that I used. But you can have a graphing calculator, or you can do it by hand. If you remember the old days, making graphs was basically connecting the dots. Let's start with one dot just so you see how you can get this. Do you see this money green dot at the origin, 0, 0? That is 1 point. Obviously you'd need many points to figure out the shape of this graph. Well, let's try that point 0, 0. If you came over here and you put x equals 0 as your input, 2 times 0 squared is 0, divided by 5 times 0 squared minus 125. You do the math, you plug in x equals 0, you end up getting 0 divided by negative 125, which by the way is okay to have 0 on top. Remember that, it's okay to have 0 in the numerator. So your y value would be 0. So your ordered pair, the dot that you'd get, 0, 0. So there's the first point on the graph. You've done it. You'd have to do it over and over for different x values to get different y values. So it would be a challenging graph. But I want to share with you, asymptotes kind of simplify your life. Turns out, all you have to do if you're using asymptotes is to choose a few points on either side of the asymptote. So literally, if you look at this, choose a large negative x value, choose a x value to the left of this first asymptote, to the right of the first asymptote, and you can start seeing pictures. It really only takes like 5 to 7 points to make that complicated picture. That's the power. So let's go back to the beginning. What are asymptotes? What are asymptotes? Well, you saw what they look like and how they're useful. Well, how many types? Turns out there are 3 types of asymptotes: vertical, horizontal, and slant. Typically, you'll only be dealing with vertical and horizontal. So let's check this out. How do we find the vertical asymptote? Really nice. It's actually pretty straightforward. Set the denominator equal to 0 and solve for x. One key note I want to share with you to give you more information than most books in one place. You can have more than one vertical asymptote. You can actually have more than one vertical asymptote. In the question we just showed you, there were 2, weren't there? X equals -5 and x equals 5. Can you ever cross a vertical asymptote? No, because essentially that's when you're dividing by 0. And remember, that's bad news. It's not in your domain. So let's do an example, an easier function. Still rational though, still have a fraction. What x value, when I plug it into the denominator, makes it go to 0? Kind of like, it's almost like you're looking for values not in your domain. So you set your denominator equal to 0, solve for x, and you get x equals 5 as a vertical asymptote. That fast to find vertical asymptotes. Then you just plot it on your graph, and then that would help you guide what the function graph looks like. So that's vertical. How do we do horizontal? Rules for finding horizontal asymptotes. Notice that HA stands for horizontal asymptote. And there's only one horizontal asymptote if it even exists. And here are the rules. So if you just follow them, it's straightforward. Look for the largest exponent in the numerator. We call that n. If it's greater than the largest exponent in the denominator, we call that m, as in Michael or Marie. Then you have no horizontal asymptote. Indeed, that's when you have a slant asymptote. That's the topic of another video. What happens if the numerator on the top is less than, the exponent on the top is less than the exponent on the bottom? Then your horizontal asymptote is y equals 0, aka the x-axis. What happens if the exponents, the greatest exponents on top and bottom, are equal? Then it's real easy. Then the horizontal asymptote is simply y equals the lead coefficient of the numerator divided by the lead coefficient of the denominator. So we know all the rules, and you can check out this video over and over to see these rules. Let's put it into action to actually come up with a solution that I showed you when you started. Let's start first with finding the vertical asymptote of this particular function. Do you remember what we're supposed to do? Set the denominator equal to 0, solve for x, and those will be your vertical asymptotes. So here we go. 5x squared minus 125 equals 0. Let's do our algebra. Take 125 on both sides. Now we have 5x squared equals 125. Divide by 5 to get x squared by itself. Remember our goal to get x by itself. Take the square root of both sides. What do I see many students forgetting? This plus and minus. That's the square root theorem, which says you need to have plus or minus the square root over here. So your actual answer is x equals plus or minus 5. Translated, x equals 5 or x equals -5 will be my vertical asymptotes. Haha! Remember when we started the solution, we drew this vertical line at x equals -5, and we drew a vertical line at x equals 5. Nice. So can we find a horizontal asymptote? Well, let's come back here again. What's the biggest power in the numerator? 2. What's the biggest power in the denominator? 2. Well, they're equal. What do we know when they're equal? Then you look at the lead coefficients. The lead coefficient is the number in front of x to the biggest power. So 2 is the lead coefficient here. 5 is the lead coefficient here. 2 divided by 5 is my horizontal asymptote. What does horizontal asymptote look like? It's a vertical line at y equals 2/5. So it's right in the middle between 0 and 1, right? And notice how they guide the graph. Question is, can we find the slant asymptote? The answer is one doesn't exist because the biggest exponent here was equal to the biggest exponent there. So you can only get a horizontal asymptote. I know that was a lot. Keep checking this video, keep working on your asymptotes. They are useful for those complicated graphs. This is the bridge for math here for you. You take care.